welcome back to my channel, and today we will together solve the daily LeetCode problem. And so yeah, for today's problem, firstly we need to count how many kind of the rectangles we have with all of the value of ones. And yeah, so in here we can see that for counting or for estimating one of the rectangle, we need to find some kind of the closed form solution. We don't want to list all of the cases. And then let's say that we are choosing the things like how can we estimate the rectangle by choosing the bottom right corner. Of course, we have another choice to choose the top left corner, but I prefer to use the bottom right corner in this case. Yeah, so let's say that we have the matrix with all of the ones in here, and then because we are fixing the bottom right corner, so here we have the 6 element, and then so we are fixing this corner. And then so how many sub matrices we have from this matrix, right? So here let's say this one is the height and this one is the width, right? Okay, because we are fixing this one. And then so firstly we have the first choice, the second choice, and the third choice. So what does this mean? This means that we are keeping this one, right? And for the second choice, we expand the window, and then so in here we have another rectangle. And next one, the third choice, we expand the rectangle, and then we have another rectangle, right? Yeah, so in this case we also have the similar thing for choosing in the vertical axis, and by this one we can iterate through the height. So in here for the number of the rectangles, we can conclude in here that is the height by the width. For example, in this case we have the 2 by the 3, right? That is the 6, right? In here of course we have the 6 smaller rectangles. This is my the way we can help us to calculate it efficiently. Yeah, however in here you can see that we not always have the perfect the rectangle. Of course this one is okay, how about this one, right? This is not true because we have the presence of the zeros in here, so it means that we don't have the perfect matrix to calculate. And however we still can apply our formula. So how can we do this? So let's say that because we depend on the height and the width, right? And then let's say that in here I will calculate all the things that is the height. So here for the second example, because I think that it is more useful, it contains more test case for us. So that one is it start by 0, and then next we have what? We have a 1, and we have the 0, right? Okay, so next we have the 0, this one is the 2, this one is the 2, and this one is the 1. This is the height, right? From this one is the first row, second row, and in here we have the last row. That one is 3, 3, and then 0. Okay, so for this one we have the matrix of the things. However yeah, in here, so let's say that we will starting doing from the last row, because on the row we will it is similar. Yeah, so for example we can do it on the last row. For example, we can consider each row independently. So here how can we see that it works will be very intuitively. Here firstly let we examine the first element. The first element is that is the 1. Okay, so it means that in here we have one pile, that is the 1, and in here we have another one with the height of 3, right? And the next one, that would be the height of 3, and this one is the 0. Okay, so we have 4 piles, and the last one is 0. Okay, so for the first one we can consist how many rectangles we have. This one is the width equal to 1 and the height equal to 1, right? And it means that we can have a height by the width, that is 1. Okay, so here we have first one, we have the run one rectangle. Okay, so how about for the second one? Yeah, this one, previously we are examining this corner. For now we jump into this corner. and then this one is 3, right? So what is the height and the width of this one? Height of this width and width of this one, we have the width, right? Let's say that let's exclude this one from now. We just like cared about like all of the height equal to 3, because like the previous one is height smaller, right? We got temporarily exclude it at the moment. So the width is 1, the height is 3, and we have the height by width, that is the 3. Okay, so how can we handle this case? How many elements we have? Because like when we I mean that if our nearest neighbor have the value of the height smaller than the current one, right? And then somehow like we always can dedicate or padding the same one on the right. It means that we are in here, right? We always can padding the same, because height of this one is 3. It means that in here like we always can padding the one in here to form the matrix with the previous one, or like form the rectangle with the previous one. It means that whatever number of the previous rectangles, we always can form the same in the current index, right, with this one. So in here like we can see that previously we can form one rectangle. It means that current one in at the current corner or the current index in here, we also can add it together. It means that we can pass the same thing to combine with the previous one to have another rectangle. So this one is the 4, right? Okay, so next one that would be like w equal to yep, so in here we move our corner to the next one. Okay, so in here we have another cases. So that case is that like what if our previous one have the equal or greater height compared to the previous one, to the current one. So this one is 3, right? And then it means what? It means that we always can form the matrix, that this one is the case of m by n. I mean the perfect matrix, right? We always can conform the perfect matrix, no matter what is like the things in here. Yeah, as long as like the height of the next one, that is the higher than the current one, we always can form the matrix with the current height, right? Current height is this one. If this one is 4, right, it's okay, we still can form that is the current height. So what is the current height in here? Current height in here, that is the 3. However, because like the previous one, we have we have seen that that is the 3 as well. So it means that we can combine it together to expand the width by 1. So it means that the width in here, that is the 2. And then finally we can have the height by width, that is equal to 3, right? However, we need to consider this case as well. We iterate, and when we see this case, yeah, so what is this case meaning? This case means that like we also can form, I mean the padding a lot of the padding the same number of the one on this and on this as well, right, to make another rectangle. So it means that in here we can have another one. Yeah, so here like this is our approach, and of course you can try to have the similar things like this. For example, this here's 1, 2, 3 and 4, right? So it means that like if we are in here, we always can form all the things with the previous one. So it means that this point, it will add up all of the point in here, this point will add up all of the rectangles in here, and this point add up all of the rectangles in here. So it means that like in here, somehow like we only need to consider the smallest, I mean the nearest neighbor, which have the height smaller than the current one, right? The 4 in here, it will like consider the 3. The 3 will consider the next one, that is the 2, and the 2 will consider the 1 in here. So gradually it can, yeah, because like we iterate in this way. So it means that if you find this one, you can add up to the next one, so on and so forth. We can form the result. And if the next and the second case is that like what if the previous one is higher than this one? It's okay, we always can form the things like this, always can merge together with the current height to solve the problem, right? Okay, so let's program it together. Yeah, I have just solved this problem and then like I run it by myself with only single hit and then single submissions, and I can solve it. Of course, like in here I include so many yeah, debugs, and yeah, so yeah, this approach is very interesting. Yeah, so firstly, another things in here is that if you can see in this way, and then somehow like we only need to store the nearest neighbor which has the height like smaller than this one, whatever like in here we can discard it directly with, and then this one is from the monotonic stack, and then because like in here like it keep increasing, and then we just push the thing like if that is greater, and then we push it into the stack. This one is the stack, right? Yeah, so for now, let's say that we have the height. We will start from very beginning. This is the thing in here, and then we gradually going down row by row, right? So here like we will get the length of the that is the math of 0. So in here like we initialize, yeah, because like we just need to keep the height in here, the length equal to this one for element. We will evolve it in gradually evolve it gradually here. Yeah, so that is the we have already initialized the heights, and then so let's say that our red rectangle, that is a 0 for example, and for now we will iterate through the matrix row by row, and let's say that like we have the initialize the index that is like -1, and yeah, so this one is the things that we will push in the stack, because like if the what if the first k in here, it means that like we need to put something on the stack first. This is like the index -0, it indicate for each row this is the starting point, and we call this one is the step results. For example, it means that like what is the result of the previous one. For example, we are if we are this one is 1, right? However, like this one it should be 0. Yeah, step result that is 0. I just put the result, and then we have the step of h. This one is the height. Let's, because like yeah, initialize with the -1, and we just like put the stack that we will get the index in, the step result in, and also we have the step h, that is the height, right? And then we will get the each element in the rows. For example, in here like we will iterate to this one, this one, and this one gradually. Yeah, so in here, so for each step, and then we need to update the height. That would be equal to height plus 1 if the current value is 1. Otherwise we will return, we will get it as 0. And so for this, and then for now we need to do something with our stack, because like yeah, we can see that monotonic stack, right? As our observation in here, we can use the monotonic stack because like we only cared about the nearest element have the height smaller than the current one. Okay, so it means that like because we put that is the okay, so in here that is the step, this one is the 2, and then if that is greater or equal than the height of I, and then we will do what? We will pop, right? It means that in here like we only keep the numbers smaller than the height in the stack. Otherwise we will discard all of the things in here, right? We, for example, for greater, we pop it, we pop this one, we put this one in the stack, right? To keep the stack is like monotonic stack. Yeah, so after that we can get the all the things out, right? So for now the top of the stack, for example, if we push the 4 out, it means that the top of the stack is now that is the 1, and then we can handle the left boundary that is equal to the stack of -1, and our index is the first one, that is the 0, and then also we can get the previous result, that is the step result in here. So it means that like previous result, that is equal to the stack of -1, the top of the stack, right? 1. And then so for now, like in here we have already got it, and we can calculate the current rectangles at the bottom right corner. So that is the previous result plus the current one, right, minus the left bound, right? It means that like we will get the width from here to here, right? The width of 2 in this case, right? This one is the 6, sorry. Okay, so in here like we buy the height of I, right? And then so we, for now, we just push it into the stack, dot append, and then we will push this one, that is the index first. The current index is I, and the step result is the current rec, and the height, current height, right? Okay, so for that, like we can get the rate of the current value, that is like current rectangles. And then so for now we just need to return the rectangles. Okay, so in here I forget to get the height, and in here that is the I, right? Previous results. Okay, another typos error. Okay, it works. Yeah, so I think that most of the people have the same way to solve the problem like me. Yeah, so thank you so much for watching my video, and yeah, if you like, and yeah, if you want to give me more motivations in the future to do more videos for you guys, please give me a subscribe or comment. Yeah, again, thank you so much for watching my video, and see you next time.